Okay, the quotient rule for logarithms. This is a rule that allows us either to expand our logarithms apart if we have a fraction on the inside, a division, or we can use it in the opposite direction. We'll do that in future videos where we have two logs separated by a subtraction. We can put those into a single logarithm. But for now, let's take a focus on expanding these, going from a fraction over into two separate logarithms. As you're going to notice on this, whatever comes from the numerator goes inside its own logarithm. That's going to be positive in front of this logarithm. Whatever goes in from the denominator gets its own logarithm. That's going to be negative in front of the logarithm. So let's expand a few of these out. We've got four quick examples. On this first one, log base 3 of 13 divided by 17. To split this apart, we're going to go with log base b. 13 goes in the first one, and it's going to be positive in front of this logarithm because that 13 came from the numerator. That's important. Minus log base b of 17 comes from the denominator, and that's as expanded out as this one's going to get. Can't break down 13, that's a prime number. The same thing with 17. We can't factor that any further. If you could, you may want to expand this even further by factoring first. All right, on this next one, we have log base 4 of x divided by z, and then there's a big fraction bar going across here, divided by w. So on this one, what I may want to do first is simply rewrite this. We have a couple different options on this. We could make this into, instead of a little fraction inside of a big fraction, we could clean that up first, or we could jump right into our quotient rule and start splitting this apart by saying log base 4 of the big numerator is this fraction, which seems a little bit strange, but it's going to be x over z, minus log base 4, and then w was our denominator from the big fraction. We can split this apart even further and expand further because we still have a fraction inside of this first set of parentheses. We can say log base 4, x is going to go on the first set, and notice that came from the numerator, so it's going to be positive out in front of this logarithm, minus log base 4 of z, and then carry down my log base 4 of w. Can't expand it any further than where we are right now. So we'll leave this as our fully expanded final answer on that one. All right, let's take a look at a little bit more complicated one. The good news is on this that they've almost completely factored this for us. There is one more little bit of factoring that I would probably do first, and it's that 15 in our numerator. Instead of dealing with a 15, I would rather factor that first and say that's 3 times 5 instead of 15. Okay, so as we get going on this, we could say log base 2 of the entire numerator minus log base 2 of the entire denominator. At first, I'm going to go ahead and write it out like that, and then we can talk about how to speed up our expanding out in just a second. But I'm going to start out with log base 2 of the entire numerator, and I'm thinking that as 3 times 5 instead of 15, times x minus 1, minus log base 2 the entire denominator, so 3x plus 4, times 2 minus x. So the numerator all went inside of one logarithm, positive out in front there. The entire denominator went inside the other logarithm, negative in front of that. Okay, now as far as expanding this out, this kind of goes back to our product rule. What we're allowed to do is put a logarithm with each one of these factors from inside the parentheses. So this is going to become log base 2 of 3 plus log base 2 of 5 plus log base 2 of x plus log base 2 of x minus 1. Okay, each one of these gets its own logarithm. They're all positive because it was positive out in front here. Minus, I'm going to put a big set of brackets going on here. I want to replace log base 2 of these two things multiplied together with something equivalent. So these are being multiplied together, so each one of them is going to get their own logarithms. But I'm going to make it as log base 2 of 3x plus 4 plus log base 2 of 2 minus x. Again, this is that product rule. But notice I included a big set of brackets around the whole thing because all of this is being replaced with what's inside the brackets. However, the subtraction out in front needs to be applied to each one of these logarithms individually. So kind of like it gets distributed. And our final answer here, I'm basically going to carry along my log base 2 of 3s plus log base 2 of 5 plus log base 2 of x plus log base 2 of x minus 1, but then distribute this negative. So log base 2 of 3x plus 4 minus log base 2 of 2 minus x for the fully expanded version of this logarithm. So a lot of work going on there. How I like to kind of shorten things up and speed this up as much as possible is if I were working this on my own, I probably wouldn't do these first two steps. I would factor the 15 from the very beginning. I'd write 15 as 3 times 5. But then how I get to my final answer, and you can do this too, is if everything's factored, each one of these factors from the numerator gets its own log. So the 3 gets its own log, the 5, the x minus 1, 5x, x minus 1. If the factor came from the numerator, it's going to be positive out in front of that logarithm. Each one of these factors in our denominator ends up getting its own log. 3x plus 4 gets its own log. 2 minus x gets its own log. However, if the factor came from the denominator, it's going to be a negative or a subtraction out in front of that logarithm. If you keep that in mind, it speeds this up immensely. So last problem, then we'll move on to a different rule. First thing I see on this one is the denominator is completely factored. That numerator is not. So let's work on factoring the numerator. I believe we have a common factor of 7x. So if we remove the 7x, we have x plus 3 inside a set of parentheses, and we factored it. Okay, from here, you may say to yourself, I'm going to completely expand this out. Each one of these factors in the numerator gets its own log. It's going to be positive. Each factor from the denominator gets its own log. It's going to be negative. Or on this one, we could actually simplify down. We could say there's a 7, there's a 7, there's an x, there's an x. Let's go ahead and simplify that first and cancel out between numerator and denominator. 7x over 7x makes a 1. So basically we can get rid of those. So we are left with a log base 3 of x plus 3. That's a remaining factor that we didn't get rid of. This came from the numerator, so it's going to be positive out in front. X minus 1, there's another factor, so it gets its own log. But this came from the denominator, so it's going to be negative out in front. Log base 3, we have an x minus 2, that's a factor, it gets its own log, but it came from the denominator, it's going to be negative out in front. And there we have our final answer. Can't do any more expanding besides that because there's no more factoring to be done. All right, hope this helps out as you're expanding logarithms using the quotient rule. Good luck.